sketch, y minus 3 squared is equal to 6x plus 2. Since we have an x to the first power and a y to the second power, this is a parabola and on a horizontal axis. But it's not in one of the standard forms. So we have this 6x plus 12. Well, let's rewrite that as, let's rewrite it as y minus 3 squared, and factoring on the right-hand side, 6 by x plus 2. So notice that this gives me the vertex. The vertex is -2, 3. And I always like to think what values of x and y respectively would make their quantity 0. If we have x plus 2, x equals -2 makes that quantity 0. And for y minus 3, y equals 3 makes that quantity 0. So we have the parabola. We know it's a parabola. We know it's opening right or left. We know where the vertex is. Let's find that value of p. For p would equal 6. I'm comparing this to the form, the general form, y squared equals 4px. And remember, thinking of that 4p as a single number. So then the 4p and the 6 must be equivalent. Since 4p equals 6, this implies that p equals 3 over 2. And since p is greater than 0, we know that the parabola opens right. So right away, I know pretty much what this looks like. So there's the vertex at -2, 3. I know that it opens right, but let's find the directrix and the focus. So remember, since it opens right, the focus is on the inside of the parabola. And it will be p units inside the parabola on the horizontal axis. So 3/2. So the focus is going to be at the ordered pair -2 plus 3/2, comma 3. -2 plus 3/2, comma 3, that's the same thing as -1/2, 3. And so the focus is here. The directrix, which is outside the parabola, is going to be p units outside the parabola. And so it would be defined by the equation x equals -2 minus 3/2, which is x equals -7/2. And so there's a very rough sketch of the parabola defined by y minus 3 squared is equal to 6 at x plus 12.